Hi dear students, welcome back to computer science class. We have learned topology, the logical layout or structure of a network in our previous session. That includes bus topology, mesh topology, star topology, ring topology and tree topology, right? Yes. So the first one was mesh topology, one-to-one connection, peer-to-peer connection. Then star topology having switch or hub. Then a ring topology having a continuous loop, all devices are connected to, and bus having a common wire, all devices are connected to, and finally tree topology having a hierarchical network, right? Yes. So today we have another very important topic for discussion. It's all about communication media. Communication media means the media that helps in data transmission, right? Yes. So there are two types of media: wired media and wireless media. Wired media can be also called as guided media, right, having a physical connection, right, okay, with the help of cables and wires. Then wireless media or unguided media, we make use of waves in electromagnetic spectrum, okay. Yes, so let's move on. Communication media is also known as transmission media, through which the data or signal is transferred from one end to another end, or between two communicating devices, right? Yes. So through wires or without wires. If the data is sent across network through wires, it's called guided media or wired media. And if it's sent without wires, data is sent without wires, it's called unguided media, right? Yes. And it's a transmission media used for sending data across network. Okay. Yes. So here is a diagram showing the division, okay, the categorization of communication media. You can see communication media can be divided into classified into guided media and unguided media. Guided media, we have twisted pair cable, coaxial cable and fiber optic cable. These are the cables used in guided media. These are all physically connected, okay, right? Yes. Then unguided media, we have microwaves, radio waves, satellite link and infrared. So about guided media or wired media, guided media also known as physical or conducted media, right? That means between the sender and the receiver. These are the two ends, right? The sender end and the receiver end, or source and destination. We can call it a source and destination of sender and receiver. That's the best terminology. So between the sender and the receiver, we will have a physical connection with the help of cables, right? Yes, that is what guided media or wired media is. So it's also called physical or conducted media, and these media use wires for transmitting data, and various wired connections are twisted pair, or various cables or wires used in guided media are twisted pair, TP, coax cable or coax simply, and fiber optical fiber cable, okay. Then unguided media without wires, that means in between the sender and the receiver there will not be a physical connection, okay. Yes. Transmission media that does not require the use of cable for transmission of data. And wireless transmission, also known as unguided or unguided media or non-physical media, right? Yes. And which uses electromagnetic waves such as radio waves, terrestrial microwave, satellite transmission, which uses radio means microwave, okay. Then cellular radio systems, then infrared transmission. Yes. Moving on. First, we can look at guided media or wired networking technologies. Okay, and you can see twisted pair cable here, right? Twisted pair cable. This is a twisted pair cable, and you can see the structure of the cable and insulated copper wires. These are insulated copper wires which are twisted around each other. Okay, which are twisted around each other. That's why it's called twisted pair cable. The structure itself is twisted like, right? That's why it's called twisted pair cable. And this is an Ethernet cable or LAN cable, which has 8 wires, right? 8 wires. You know the difference between wire and cable, right? Wire means it can be single stranded, and cable means we'll have multiple wires, right? And this is a cable. This is a twisted pair cable, or we can say Ethernet cable. Okay, we have 8 wires or 8 insulated copper wires here in this cable. Okay. So a twisted pair cable is the oldest, simplest and the most common type of conducted media. It's made up of 2 insulated copper wires which are twisted around each other, twisted together to form a single wire. And we consider this as a single, okay, even though we have 2 strands, okay. Then each wire is 1 millimeter thick, and one is used for data carrying and other is used for ground reference, okay. Some other related aspects of data carrying, that's what ground reference is. Then the wires so twisted are helpful for that means the twisted structure will be helpful for avoiding interference from nearby devices or nearby pairs. That is called crosstalk. You might have learned the concept of interference in physics, right? And here in communication or electron communication, okay, it's called crosstalk. That simply we can call it as disturbance. Okay, disturbance. Yeah. So twisted pair can be specified as category 1 to 5. Okay, or cat 1 to 5 it's called. Then category 6 twisted pair can support data transmission as high as 200 Mbps to 400 meters, while category 7 supports higher than, right? Yes. So category 6 and 7 supports high data transmission in terms of both data carrying and the data carrying capacity as well as the distance it travel. Okay. Yes. Then twisted pair has two varieties: shielded twisted pair and unshielded twisted pair, or we can say STP and UTP. From the name itself, we could say shielded twisted pair. It has a shield, right? Are covered in metal foil. This makes them indifferent to noise and crosstalk. That means we can avoid crosstalk or interference to a great extent. Here when we use shielded twisted pair, but the problem is this is somewhat very costly. Okay. Other than unshielded twisted pair, then UTP has 7 categories is suitable for specific use. Okay, we mainly use unshielded twisted pair, mostly category 5, 5E and category 6. Okay, and which are connected by RJ45 connector. You know, that's a standard connector. Registered jack 45 connectors. Okay, so this is about the structure and the function of twisted pair. Twisted around each other, 2 insulated copper wires, 1 millimeter thick, one for data transmission, other for ground reference. Then interference. Okay, to avoid interference, that's why the structure is like twisted. Okay, yes. Then 2 types: shielded and unshielded. Then advantages: it's simple to use, of course. It is inexpensive and does not require any skilled personnel for implementing. Then it is less susceptible to electrical interference caused by nearby equipments. Okay, or wires. Then the media can be used for both analog and digital, which can be used for both analog and digital. Okay. Then if the portion of twisted pair cable is damaged, the entire network is not shot. Of course, there will be problem, but the entire network will not be affected by that. Okay. Yes. Then disadvantages: STP wire is physically larger and more expensive than twisted pair, as we have already seen that, right? Then STP is more difficult to connect to terminating block. Okay, that means there may be some issues with compatibility. Okay. Yes, between STP and UTP. That's what terminating block connecting to a terminating block will definitely have a problem. Terminating block means the end block. Okay. Yes. The end, that's it. And it easily picks up noise signals and results in higher error rates. Okay, yes, when it exceeds 100 meters. Of course, there will be problem when it travels long distance. We need the help of repeaters, right? Yes. Being thin in size, likely to break easily. Of course, it's flexible as well. Okay, it can support 90 to 100 bps to 50 feet. Okay, 235 to 30 to 4. Okay, yes. So these are the advantages and limitations of twisted pair cable. Okay. Our second one is coaxial cable, and first we can look at the structure. Okay. Yes, you can see an outer jacket. This black one, outer jacket. Of course, it's a plastic or rubber. Okay. Then metal shield, braided shield, metal shield. Okay. Then foil shield. Yes, foil shield, and finally you can see standard conductor, that is copper wire. Okay, before that we have it's covered with dielectric. Okay, so this is the structure, and we have an outer jacket, braided shield, foil shield, and dielectric, and of course standard conductor. Okay, copper wire. So we have a lot of coverings, right? Lot of coverings. So it will be very good in transmission of data without losing data. Data carrying capacity will also be higher. Then it has it is less susceptible or subjected to what we can say interference or crosstalk. Okay. A coaxial cable is generally called coaxial. It consists of insulated copper wire surrounded by a braided metal shield and covered in a plastic jacket. Coaxial cables are capable of carrying higher frequency signal than twisted pair, of course. The wrap structure provides it a good shield against noise and crosstalk. Okay. Yes. Coaxial cable provide high bandwidth rates up to 450 Mbps. Okay. Yes. We have thin coaxial cable and thick coaxial cable, and 3 categories of coaxial cable: RJ59 cable TV using cable TV, RJ58 thin Ethernet cable, then RJ11 thick Ethernet. Okay. RG stands for radio gain. Okay, radio gain. Then coax cables are widely used for internet connections and cable televisions. You might have seen it, right? And it's mainly used in cable internet connection and cable TV connection, right? Yes. Then advantages: coaxial cable can support greater cable length between lens between a network device and that twisted pair cable, okay, other than twisted pair cable. It's useful for transmitting analog as well as digital signal, okay. Wide used for cable television and cable internet connection. Then coax are used for transmitting several channels simultaneously, and has excellent noise immunity because of that thick covering, okay. Yes. Then thick coaxial cable has an extra protective plastic cover that helps in keep moisture away, okay. Yes. It is relatively inexpensive as compared to fiber optic. And the distorted edges. A thick coaxial cable does not bend easily, so difficult to install, okay. That is not flexible. And it is it's an expensive one as compared to twisted pair cable, of course. Yes. So these are the disadvantages, and that is the structure as well as the functioning and how it transfer data in the case of a coaxial cable. Okay. Yes. Mainly used in cable internet connection and cable TV connection. Okay. And finally, we have in wide connection we have fiber optic cable. Here is the structure of fiber optic cable, or we can call it as optical fiber cable. Okay. Yes. Here is the structure. We have a jacket here, okay, and a cladding. Then we have buffer coating, okay. Then we have the core. This is the core, and you can see this image. Actually, optical fiber cable consists of thin strands of what? Glass or plastic, okay. Glass or plastic. The difference is in the case of twisted pair and coaxial cable, it uses what? Electric pulses, okay. It transmits data in terms of electric pulses, right. And here in optical fiber cable, as the name suggests, optics, it's a branch of physics, deals with the study of light, right? Yes. So, optical fiber cable transmit data in terms of light, okay? So, that means other than electric pulses of transmitting data in the case of twisted pair and coaxial, here in optical fiber cable, it transmits data in terms of light, okay? Yes, that's the difference. So, we know light is very fast, okay, in transmitting anything, data, of course, yes. So, it is the fastest means of communication, and today it's used for connecting very long distances, even continents. Okay, yes. Then fiber optic transmit light signals rather than electrical signals, electric pulses, of course. And it is the newest form of gated medium. Several glass fibers are bundled together and are encased in an insulated covering. Light signal traveling into fiber optic cable and at one end and are received at the other end. Okay. Yes. When the light enters into fiber optic, light pulses inside the cable hits the outer wall of the wire and similar angle. Okay. Yes. So the outer surface. Okay. Yes. The light source used in this process, light emitting diode. Okay. That means LED. LED light emitting diodes are used there inside the fiber optic cable. Okay. Yes. Then optical fiber cable. Actually, why we use light emitting diode? Actually, sometimes when it travels more than 100 kilometers, of course there may be a need of repeaters. Okay, so here light emitting diode acts as a repeater. Okay, yes. Then optical fiber may be single mode or multi mode. There are different variations of this. Okay, we don't have to look at all these points. Okay, yes. Then yes. Then advantages of fiber optic. Fiber optic typically offers better bandwidth and data carrying capacity. Then as signal travels in the form of light, less attenuation and degradation of data. Okay. Yes. There won't be any problem with the losing of signals or losing the strength of the signal or shape of the signal. Okay. Yes. That's what attenuation distortion is, right? Attenuation means changing the shape of the signal. Sorry, changing losing the strength of the signal, right? Yes. Then optical fiber cable are made of glass. Okay, little risk of fire because of absence of spark. Okay. Yes. Fiber optic cables are much thinner and lighter, and lighter weight make easy to install. Then, but it needs an expert to install this, right? Okay. Yes. It does not make leak signals. Okay. Run for 50 kilometers without requiring regeneration or repeaters. Then most of the time it travels 100 kilometers, okay, without any repeaters. That's it. Then fiber optic cables are also used in research and development. Okay, hardly. Yes. Then we have highly skilled laborers required for installing this, and it's relatively expensive as compared to other gated media like twisted pair and coax. Then it's made up of glass. Okay, travels in straight line. Okay, Yes, bidirectional communication is also possible even then. Yeah. Then we have, okay, this is all about guided media or wired media. We have seen twisted pair, coaxial, fiber optic, right? Yes. Then unguided media or wireless networking technologies and features of unguided media. Transmission and reception are achieved by means of an antenna. There will definitely be an antenna that's access what transmitter and a receiver. Okay. Then can be either directional or omnidirectional. Directional means transmitting antenna puts up progress beam. Transmitter and receiver must be aligned. Okay, must be aligned properly. And omnidirectional means spread out in all directions and receiver can receive. Okay, that means antenna can be used for receiving the signal. That's what directional, omnidirectional is. Okay, directional means having a direction. That means the sender and the receiver must be aligned properly. The transmitter and the receiver must be aligned properly. Okay, then only it can transmit and receive signals. And transmitter and receiver, these are two devices, and we can together it forms a transceiver. Okay, it's called transceiver. Yeah. Then in omnidirectional, it's spread out in all directions, and signal of the receiver receives the signal. That's it. Okay. Then microwave, that's the first one. And these signals are used to transmit data without the use of a cable, and it's a line of sight transmission. Okay, line of sight transmission. That means sender and receiver must be aligned properly. That means a line of sight is needed. Okay. Yes. Transmission line of sight. Do you get it? Line of sight. This is what a line of sight is, right? And there must not be any obstacles between sender and the receiver or transmitter and the receiver. It must be in a line. Okay. Yes. Line of sight in a line. And travel straight line. Of course, it travels straight line. And microwave communication to bidirectional. Two-directional parabolic antenna are mounted on towers, okay, buildings or hills, okay, to send and receive signals to airs. This properly aligned to each other with each other. Otherwise, the signal will not be focused well. Okay. Yes, that means line of sight communication is needed between the transmitter and the receiver. That means it must be in a straight line. Okay. Yes. Then advantages, it's cheaper source of communication and it's avoid cables. Okay, of course we know that. Repeat this. Then communication through microwave much easy over difficult terrain. That's the main advantage. We use this microwave for transmission of data in a difficult terrain. Okay, where that wired media is not possible. Some other media like even wireless media like radio and some of them may not be possible. Okay, these are actually microwaves. We can term it as super high frequency radio wave. Okay, microwave can be termed as super high frequency radio wave. Then a microwave system permits data transmission rate of 16 gigabits per second, okay, up to about. Then disadvantages, insecure mode of communication. Signal can split and propagate in different directions of air, okay, and in air. Then propagation affected by weather conditions such as rain, thunderstorm, or all that, okay. Then cost of implementation is very high, okay. Yes, towers, antennas are good. Second one is radio waves, and we know radio waves are the most commonly used waves. That is the cheapest. Okay, line of sight communication is not needed. It travels. Okay, it bends. Of course, yeah. Then you can see here radio, and this is the one used in most of the communication technologies like mobile communication, radio, TV, then Wi-Fi, WiMAX, all that. Okay, radio waves are used for which use radio frequencies which are allocated to private business for direct voice communication. A radio serve uses transmitter and receiver. A transmitter sends radio waves and encodes them into sine wave, okay, which then received by the receiver recorded the actual message. And both transmitter and receiver use antenna to radiate and fetch signals. Okay, like they are not line of sight transmission, and hence okay, penetrate building easily. Of course, that's the main advantage of radio wave. And you know, spectrum allocation by the government. Okay, you might have seen spectrums, means the scam, 2D, 3D scam, right? So it belongs to this. Okay, yes. That means specific frequency band is allocated to each company. Okay, yes. For example, radio 91.9, which uses it's a radio channel, right? 91.9, which uses a specific frequency band. 93.4 uses another one. 95 uses another one. Okay, yes. That means separate frequency band is allocated to different companies. Okay, private or public, whatever it is. Yeah. Then advantages, they can use indoor or outdoors. Okay, omnidirectional can travel in any direction. Then transmitter and receiver antenna does not get physically aligned. Okay, Yes, that means line of sight is not needed here. Radio transmission offers mobility, cheaper, offers ease of communication. Radio is okay. Then disadvantage is insecure mode of communication. Of course, everything is insecure. Okay. Nothing is ideal. We know that. Okay. Then radio wave propagation is susceptible to weather. Of course, this are affected by rain, thunderstorm, etc. Because when we use mobile phone at the time of rain, it's getting disrupted, right? It's getting disturbed by rain. Yes. Then satellite communication, another one, okay, which is somewhat very costly, of course, with the help of satellite. We know the structure. Here is the satellite, then transmit the signal, we know uplinking and downlinking. Uplinking means to the satellite, okay. Downlinking means from the satellite. That means data transmitted to the satellite is called uplinking, and data downloaded or receives from the antenna, receiving antenna is called downlinking, okay. Yes. Then satellite transmission is also a kind of line of sight transmission. Of course, this microwave and infrared, which need line of sight communication. Okay, used to transmit signal throughout the world. It offers very large scale of transmission of data. When frequency is greater than 3 gigahertz, the transmission is known as microwave, and special microwave transmission medium. Okay, provides various type of devices such as transmitting voice, fax, video, email, other internet applications. Okay, then yes, satellite dish. You can see antenna, dish, all those devices. Okay, then from Earth to satellite, known as uplinking. That means data transmitted from the Earth to satellite is known as uplinking, and transmission takes place from satellite to the Earth is known as downlinking. You might have seen the downlinking and uplinking frequency of TV channels, right? Yes. Then the area covered is very large. Then no line of sight communication is needed. Earth station receives can be fixed, can be at a fixed position or can be relatively mobile. Okay. Then based on the placement of the satellite, we have different areas. Okay. Geostationary Earth orbit, medium Earth orbit, and low Earth orbit. Okay. Low Earth orbit mainly covers a small distance like an area, okay, like somewhat a state, like Kerala, Tamil Nadu, okay, or a group of states, okay, to very low Earth orbit, and then MEO, it covers maybe India, okay, yes. Then the other one, GEO, which covers the means different continents, okay, yes. It offers a high area, okay, yes, vast area. Disadvantage is expensive, installation is very complex, signals and can be interrupted. Okay, of course there will be problem. Then low antenna gain results of overcrowding of available bandwidth. Okay. Then next one is the last one is infrared, which is the one used in TV remote, car remote. Okay, the type of transmission that is infrared to send data is known as infrared transmission, and the data is transmitted through air and can propagate in open space. However, it cannot penetrate the walls. Okay, like microwave. Then it's an example of short range transmission. 2.4 kbps to 16 mbps. Okay. Example TV remotes, AC, all these are examples. You can see transmitter, receiver, transceiver. Here also transmitter, receiver. Okay. Yes. Then it's a secure medium of transmission. Okay. This is only secure medium. Yeah. It's a cheap mode of communication and work only short distance. That's the problem. Confined to short distance and cannot penetrate walls and noise and be affected by. Then wireless technology. These are some of the. Now we are going to look at the technologies. Okay. So this is all about the different wireless communication media or unguided media. Yes. Then we are going to look at the wireless technologies. Okay, different technology that uses wireless communication. And wireless technology is the process of sending information through invisible waves and data. Any kind of data can be transmitted. Okay. Wi-Fi. Let's look at Wi-Fi first. Okay. Wi-Fi stands for wireless fidelity, and it's used to set up a wireless LAN. Right. Wireless LAN. Normally LAN is wired and Wi-Fi offers wireless LAN. It's wireless fidelity where communication takes place without wires, and the users share the data with each other by connecting to the broadband internet service provider. Okay, using cables. Yeah. Then it's not a secure media of transmitting data. Yes. Okay, which can be used to connect laptop, desktop, and everything. Okay. Then WiMAX. WiMAX means it's so wireless. Okay, please don't misunderstand. It's wireless. It's worldwide. Okay. Worldwide interoperability for microwave access. It's a wireless communication system that provides broadband internet access up to 30 miles. Okay, Yes, without voice, provides up to 30 to 40 megabits per second or up to 1 Gbps. Okay. Yes. Then used based on the IEEE 802.16. Okay. IEEE 802.16 technology. That's a technical terminology for WiMAX. Okay. And IEEE 802.6 is a standard of Wi-Fi. Okay. And IEEE, you know what IEEE is? Institute of Electrical and Electronic Engineers. Okay. Yes. It's an international organization that controls and monitors the development and communication. Okay. It's a group of engineers. Okay. Yes. Then it's used to set up WiMAX is used to set up wireless LAN. Okay. Yes. Then we have other unguided media, laser technology. You know what laser is, right? Laser stands for light amplification by stimulated emission of radiation, and it's a mode of wireless communication, transmission medium that requires direct line of sight. Okay, yes, it provides point-to-point transmission between points located short distances. Okay, such as building similar to microwave. It's unidirectional, much faster, of course, and it's of course it's a way of communication. Okay, and laser technology is used in what in operations. Okay, in medical industry as well. Yes. Disadvantage associated with is badly affected by weather condition, of course. Yes. Then Bluetooth technology refers to telecommunication industry specification that define how different devices can be connected virtually. Okay, and it's a kind of a PAN, right? Yes. Personal area network. Okay. Then establish wireless connection in the form of wireless LAN. Of course, it can also be thought of as what wireless LAN as well. Okay. Yes. Or PAN. The PAN is a correct terminology, and we can think it of as wireless LAN as well. Okay. Yes. Transmission of information using Bluetooth with a low cost transceiver chip. Okay. Yes. And based on IEEE 800 standard. Yes. So these are the different ways of connecting the sender and the receiver for transmitting data. Okay. Wired and wireless. Wired, twisted pair, biaxial, and fiber optic. Okay. Then wireless, the microwave, radio, satellite, and finally infrared. Right. And we have seen wireless technology, Wi-Fi, WiMAX, then laser technology and Bluetooth. Right. Okay. So this is all about transmission media. Okay. Just go through all these topics very detailed. Okay. So because these are very important topics. Okay. For your board examination and for general awareness. Okay. Yeah. So this is all for the time being. Thank you. Thank you for watching. Have a nice time. See you in the next video. Take care.